So, as I said earlier on, a key idea behind the strategy used to integrate combinations of products and powers of sines and cosines involve rewriting these expressions as sums and difference of integrals of the form integral of sine power n of x cos x dx, or integral of cos power n of x sine x dx. So this is one of the strategies that you must use to rewrite them in such a way that you'll be able to compute the integrals. So after rewriting these integrals, you'll be able to evaluate them using your use substitution. You know, the use substitution that we learned earlier on is also useful here. And before describing the general process in details, please let's take a look at some examples so that we'll be able to understand it clearly. So basically, first of all, let's look at integrating cos power n of x sine x. The n can be of any number. That's the power of it. You know, cos square is a 2, and if n is 2 is cos square, if n is 3 cos cube, if n is 4 cos power 4 of x. That's what the n means or stands for. So let's look at this example, like integrating integral of cos power n of x sine of x. This means that for the question is a product of the cos and the sine, but the difference is that now the cos is having a power which can be more than 1, but the sine is having a power of 1. That's kind of example that we are going to look at right now. So first of all, example 1 evaluates the integral of cos power 3x sine x dx. So this is a major example of whatever I've written over here. A major example of whatever I've written over here, right? So this means the n is 3 over here, so as you can see here, but the sine is having a power of 1. So in doing this is simple. You can do use substitution to help you eliminate sine x. When you get some questions like this, the only option, or let me say, whatever you need to focus on to how will you be able to eliminate one of the trigonometric functions or the ratio and leave everything in terms of one ratio. For example, cos is one of the trigonometric ratio, right? And then the sine is one of the trigonometric ratio, right? And when you get a question like this, you ask yourself, how can I make everything in terms of cos so that it will be easy for you to integrate? Or how can you make everything in terms of sine so that it will be easy for you to integrate? So looking at this one, you can apply your simple use substitution for you to help you to solve this. And applying simple use substitution, your aim is to eliminate one of the ratios. And when we are applying use substitution, we can say let our use substitution u equal to cos x. And when we differentiate cos, we will get sine. And remember that when we were doing the use substitution, we wanted to represent everything in terms of u, and therefore we need to replace what? This one, the dx. And when you replace it, that will help us to cancel this sine value out, and you will be left with only the cos function. So let's proceed and see how we do it. So in applying our u substitution, you can say let our u equal to cos x. Therefore, our du dx, as we did in our use substitution, is equal to negative sine x dx. As I said, the integral, the differential of cos and sine should be on your fingertip together with their integral, because one is the reverse of the other. So the du dx is equal to negative sine x dx, and therefore making dx the subject, you need to multiply both sides. So let me not confuse you. So let me clean here first. Yeah. So this du dx equal to this. So when you want to make du dx the subject, let's multiply both sides by dx. Here by dx, and you cancel this. So we are going to get du equal to negative sine x dx. This is how we came about du equal to negative sine x dx. And if we want to make dx the subject, we can divide both sides by negative sine of x. So we are going to get dx equal to 1 over negative sine of x du. So now these are the x. And remember that during our previous tutorial, I told you that so as far as you say make u equal to cos x, the original function changes. So if the original function changes, the function that you are currently working on becomes u power 3 sine what? X. So in this case, let's replace our dx. When we replace our dx, we are multiplying it by, because now dx is here, right? Replace by dx. So when dx is equal to 1 over negative sine x du. So we are going to get multiply by negative 1 over sine x du. So as you can see, this one will cancel this one out. When I cancel it out, you are going to get integral of u of 3 du. Now you can see that everything is in terms of u, and now you can apply your normal power rule for integration. So you are going to get u power 3 plus 1 over 3 plus 1, right, which is equal to u power 4 over 4. And don't forget it's the indefinite integral, so you bring your constant of integration, which is O plus c. And therefore, remember that we said let u equal to cos of x, and for that matter, we need to replace it, and you are going to get cos of x all power 4 over 4 plus c. And don't forget that they are negative, because there's a negative attached to this, so negative is here and negative is here. So don't forget that. So this is one simple way that you'll be able to integrate a product of sine and cos, where the cos is having a power and then the sine is not having a power. So, since you now understand whatever I did right now, I would like to give you one trial question for you to solve. This is a trial question. Please pause the video and try them, and I'll give you the final answer to compare your answer if you are right or wrong. Please try your hands on it several times to make sure that you are conversant with it. This is the same as what we did. You do the same. There's nothing changing. But one thing that you are going to do is that now, for the first example, it was only the cos which is having the power, and then this one, it's the sine which is having the power. So you can say let your u equal to the sine of x. That's all. So you can try and the final answer should be The final answer should be 1 over 5 sine power 5 of x plus c.